Last episode, you killed the for loop with vectorization, one operation over a whole array, but that assumed both arrays were the same shape. What happens when a column meets a row? NumPy doesn't complain, and it doesn't copy a thing. It stretches them to fit. That's broadcasting, and it's how every distance table, every score matrix gets built. Here's the rule, and it's the whole episode. Line the shapes up on the right, walk left. At each position, the sizes must either match or one of them must be 1. A 1 gets stretched to meet its partner. If neither is true, NumPy raises an error. That's it. A column vector is shape 4 by 1. A row vector is shape 3. Stack them right aligned, 4 by 1 against 3. The trailing pair is 1 versus 3. The 1 stretches to 3. The leading pair is 4 versus nothing. The missing dim becomes 1, then stretches to 4. Result 4 by 3. And here's the part that matters for your memory build. That stretch is virtual. NumPy never builds a 4 by 3 copy of the column or the row. It reads the same values with clever strides. You get a full table at the cost of 2 small vectors. So a multiplication table, a distance table, and outer product, they're all the same move. Reshape one operand to a column, leave the other a row, and let the shapes collide. One line replaces a double loop, and it's faster because nothing copies. Here's the program. Seed default RNG7. Draw a length 4 vector A and length 3 vector B, both small integers. We'll build their multiplication table by broadcasting and prove it equals the handwritten double loop. A is shape 4. We reshape it to a column with A reshape 1, 1. That -1 means you figure out the length. Now it's 4 by 1. B stays a row, shape 3. The whole computation is one expression, call B, 4 by 1 times 3. NumPy aligns right, stretches the ones, and hands back a 4 by 3 table. No loop in sight. To prove it's not magic, we fill the same table the slow way, a double for over rows and columns, then assert NumPy array equal. They match exactly. Broadcasting is that loop minus the loop. Run it. The shapes print input 4, input 3, column 4 by 1, result 4 by 3. The loop check is true, and reseeding reproduces A and B to the digit. Read the table. The top left to bottom right values run from 12 up to 25. The biggest cell is 25. That's a 95 times book, 5. The whole table sums to 216. Terminal, figure, headline, same numbers. Broadcasting stretches shapes virtually. No loops, no copies, just strides reading the same memory. You built a full table from 2 vectors. Next episode, once you have a table, how do you pull out only the cells you want? Fancy indexing and Boolean masks, selection without loops.